Hi viewers, welcome to LMS Solution. Today we are going to see about PV and wind energy system based EV charging station in MATLAB. This is a simulation model we developed for PV and wind energy system based EV charging station. So this model consists of a wind energy conversion system and then PV power energy system and then EV battery. Here we are having EV battery, that means the battery will be connected with the PV and the wind energy system always. And then here that means we can use that battery like swapping concept. Whenever EV have need that battery, so they can load that EV, that battery of that EV, and then they can take this battery for drive that EV, like swapping of EV battery concept. The swapping of EV battery concept, this kind of arrangement we can implement for EV battery charging. Here you can see that the model consists of wind turbine, permanent magnet generator, and then rectifier, and then boost converter. Then this boost converter going to be controlled by means of P&O MPPT. This P&O MPPT receiving two inputs. One is rectifier voltage and rectifier current, and then it going to be processed via P&O MPPT. This code for that P&O MPPT. Here we have to provide that for detail like initial duty cycle, maximum duty cycle, minimum duty cycle, small change in duty cycle, and then you have to initialize three parameter like previous instant voltage, power, and duty cycle, and then you have to calculate power, change in voltage, change in power. Based upon change in power, change in voltage, you have to increment or decrement the duty cycle in order to get the maximum power from the wind turbine. This code will be keep on executing in order to get the maximum power from the wind turbine by adjusting the duty cycle of this boost converter. And then here we have PV power generation, the PV panel. So here we have around 2000 watts PV panel, and then this wind turbine will be generated around 2.5 to 3000 watts. This PV will be connected to this DC bus. So this is the DC bus via this boost converter. This boost converter, here we are going to control that boost converter via first MPPT. It going to receive two inputs, PV voltage and current, and it going to be that means based upon PV voltage and current, you have to calculate change in power, change in voltage. That will be change in power will be that will ratio of change in power to change in voltage going to be considered as one input, and then the rate of change of that del P by del B going to be consider another input. The output will be duty cycle, and it going to be processed via this pendulum generator, and then it will be generated pulse for this boost converter in order to extract the maximum power from the PV panel. In common DC bus, we are going to directly connect that EV. This EV battery, EV battery going to be connected directly to the DC bus. Whatever power is generating from this wind and PV, that going to be used for charge that battery. So we can connect to more than one battery also, EV battery also, for taking power from this wind and PV. And then we can use swapping method for change the battery for charging. When we having empty battery, then that battery will be connected here to charge, and then you can take the charged battery from that the EV charging station. So next here we have different conditions that the EV battery going to be charged. So here we consider the every 0.3 second irradiation will be changed from 1000 to 500, and then 10, and then again 500, 1000 for every 0.3 second. And then here we are changing wind speed from 12 to around 10.8 meters per second after 1 second. And you have to check the response of the system. Here we can measure the power of wind, and then here you can measure the power of PV, and here you can measure the voltage and current of battery. Here you can measure the SOC of the battery. Here you can measure the power of PV, wind, and battery. Here I am going to simulate this model. Here every 0.3 second irradiation will be changed. Here after 1 second rate irradiation, that means wind speed change from 12 meter per second to 10.8 meter per second. So here you can see that for 1000 watts per meter square, the PV power will be 2000. For 12 meter per second, that means boost converter power around 2500. Charging current will be around minus 10 amps. So here you can see that here you can see that the battery power charging power around 4000 watts during 1000 watts per meter square and 12 meter per second. When irradiation equal to 500 watts per meter square, the charging current around minus 8 amps, minus 7 amps, around 7 amps, and then here that wind will be supply around 2500. Here you will see that this is a PV power, wind power. This is a charging power of that EV battery. Here you will see that the at 10 watts per meter square the PV power is around 0, and then here you can see that the charging current goes to around -6 amps. Here you will see that during that time wind speed will be 12 meter per second. It will be generated around 2500 watts that will be used for charge that battery from wind. After that you can see that the PV power is very increasing by increasing the radiation, and also you can see that charging power and the charging current of the battery also increasing as per that increasing power of PV. And then this is the graph for the SOC of the EV battery. Here you can see that we can connect more number of battery for charging. This is a small power rating model. We can increase the power rating of wind and increase the power rating of PV. That's why you can add more number of EV battery for charging at a time, and then we can use a swapping up for using this kind of a EV charging station in real time. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.